that's not going to be new for us. But these other ones, these three now down here. So first of all, we're going to be dealing with right triangles right now. When we get into chapter 8, we have obtuse, scaly triangles. The SOHCAHTOA, I'm probably pretty sure that was discussed in geometry. This acronym that helps me remember sine, opposite hypotenuse, and cosine, adjacent hypotenuse, tangent, opposite adjacent. But what still trips people up is, how do I know what the O and the A are? First of all, let's get this straight. The H, the hypotenuse, is always an H. Never changes. It's the longest side of the triangle. It's always across from the 90-degree angle. But these O and A's, they are dependent on the acute angle we are looking at. So in this first example with theta hanging out down here, the opposite is the side it's eaten by the angle. And so if my angle is theta, you can imagine this thing having teeth. It's going to eat the opposite side. Okay? Now, sometimes, though, that angle moves. It goes somewhere else. And maybe it camps out up here. Let's give it a new, that's called a gamma. It's a Greek letter. So, sometimes my angle is up here. And now I'm eating the other side. Now I'm eating this. And that would become my O. So the O and the A depend on where I'm at with my angle. The O gets eaten. The A is a part of the mouth along with the hypotenuse. So A makes my angle, O eats my angle. Does that help? Does that help think of it that way? Did I confuse anybody with the whole concept of eating? No? All right, that's good. All right. So that's what's going on with O's and H's. So here are three new functions. You guys have never seen these before. Well, maybe you have. The reciprocal guys. So if I take a sine function and I do 1 over sine, that becomes a cosine. Cosine function, 1 over that becomes a secant function. Cotangent is a 1 over a tangent. Well, if my ratios flip, if OH flips, I get HO. And AH becomes HA. OA becomes AO. Now you won't actually have these. On most calculators, you don't have these reciprocal functions. Most of you guys just have sines and cosines and tangents on your calculator. So in order to find these reciprocal functions, we use the sine, the cosine, and the tangent, and we just take the reciprocal answer of it. What else should we point out? It always tends to confuse people. The theta or the x or whatever it is that's hanging out after the sine, cosine, tangent is always an angle. So these are angles. And then what you are equal to, this part, is a ratio. So sometimes that gets confused, especially when we start talking about inverse or arc, cosine, arctan. You guys heard of that stuff before? Yeah? So what is it, Bobby? What's an inverse or an arc? Tangent. Oh, you've heard it, you should know what it is. Anyone else know what it is? Heard of it? No, it might be new. It finds the angle. So if I have, let's say the sine is equal to 1/2, but I want to know what angle produces that, then I do an inverse. And those buttons are also on your calculator. Those are those buttons that say sine -1 power, cosine -1 power, and so on. All right, so a lot of stuff going on here. So talking about the eating part, when I have a theta and how I have an opposite side and an adjacent side, we have this complementary, or they're also known as cofunction relationships between sines and cosines and secants and all that stuff. So taking a look at hanging out here at theta, the sine of that angle is the opposite over the hypotenuse. Now if I were to do that, in fact do this, you guys have your calculators out? Can you do this for me, pull them out for me, and then put in the sine of 30. Now, first of all, make sure you're in degree mode, which you probably are already default So when you do sine of 30, you get 0.5. Yeah, does everyone else get 0.5? Yeah, okay, cool. So if the sine of 30 degrees is 0.5, then by this relationship, this cofunction relationship, that would mean that that would be equal to the cosine of negative, or not negative, 90 minus 30. So now do the cosine of 60, and you should also get 0.5. Yeah. So those are called cofunction relationships. Yeah, it is crazy. Now here's another thing that's interesting. Look at this. Started with a sine, then it became a cosine. And it was a tangent, and it was a cotangent. A secant became a cosecant. So that's where those are related. But you never knew that. Chalk that one up for learning new for today. One item learned new for the day. All those are probably like your ninth item for the day, right? At least. All right. So what was your question? Okay.
I had it.
Oh, you had it, and then it just disappeared. That happens sometimes when you get older.
Well, I'm also trying to like formulate what I want to say.
Okay. Maybe it'll come back to you. Maybe just stand up and walk backwards. It'll come back to you.
I tried it.
Sure, yeah.
Okay, so
This is gonna work. Walk backwards. Start talking backwards. Did it help?
kind of. Okay, so sine 30. So that degree is that right?
Whatever theta is.
Yeah.
Yeah.
So that's 30, and then so you take 90 minus, or you take 90 minus.
Yeah. Do you know why? Do you know why we're doing 90 minus? Maybe we should start that conversation. Why are we doing 90 minus this? That's a good question. Anyone know? Because triangles add up to 180, and there's already a 90 here. So these two angles will always be a sum of 90 degrees. The two acute angles must always add up to 90.
Okay.
So that's why we're doing 90 minus.
Oh, I get it.
Yeah? Yeah. Well, we'll see if you get it. All right. So sometimes we're going to have exact values. That's actually 2 sections from now when we're talking about exact values, because we're going to have 2 special right triangles we're going to look at. But until then, we have this calculator, which is a nice tool for us to find the answer. So let's make sure we just know how to plug things in. We're talking about making sure 2 things happen when I'm using the calculator. One, I need to check the mode, because your mode is either going to be degrees or radians. Yeah, how do we change it? It's dependent on your calculator, so I might need to... now we want to find, let's try what happens when you do the inverse or the reciprocal moves. So how about the cosecant of 42 degrees? Now, how do we do this on the calculator? Because most of your calculators do not have a cosecant button. It's not the opposite of sine, it's the reciprocal of sine. So how do we do this? We go like this. We go 1 over sine of 42, and that is what the cosecant of 42 is. No, good question. Good question. Sine with a negative 1 on it on your calculator does not equal 1 over sine. Oh boy, that's a new word. What this is, we just mentioned it a little while ago, this is called an inverse, or an arc sine. And it helps me find an angle. This is a reciprocal. They're different. Okay, so that was a good question. They're not the same thing. I physically have to go 1 divide sine 42 and then answer. What'd you get, brother?
Did you say calculator have the origin?
Yeah, if we're talking about 42 degrees, I would be in a degree mode, which is probably already default.
Yeah. L1
1.49.
Yeah, yours is already extreme, but you're good. Oh, that's my answer. So here's what Jen read, 1.494. You guys get that?
Yeah.
So this equals 1.494. And that would be the case for secant and cotangent. I do 1 over my value, and then there's my answer. All right? So I doubt that probably you guys have the fancy calculators that have the reciprocal functions in them. You have that one?
Yeah, you have to go into like
Yeah, you got to go way deep into the modes there. All right, any questions on calculating based on here's an angle, let's find our ratio. Remember, what we're finding is the ratio. That's what these are. Each of these, like for the sine, this is a ratio of a y over an r, or you're probably more familiar with an O over an h. If I had a triangle, that would be the ratio of the sides. And this would be an A, this one would be an A over an H. And this one would be an O over an A. Again, if we're thinking about a triangle. You doing all right so far? Okay. All right, so then let's take a look at the inverse function and how we can find my angles. So that sine -1 button now is going to come into play. When you're looking for angles, how do you know you'll be looking for angles? One of two ways you'll be looking for angles. You will actually physically, in the problem, see sine, tan, cosine, -1 power. That means you're going to be finding an angle, which means you should already have been given or have been able to find these parts of the problem. I need to know what the ratios are to be able to calculate the angles. So sometimes we're going to have like a triangle that we will see. And based on that triangle, I might have two sides given to me. And based on those two sides, I decide if they're opposites or adjacents or hypotenuse. And I pick which trig function I'm going to use to find the angle. Sometimes you'll say, find the angle of the inverse sine of 0.76. Well, that just means we're going to go inverse sine 0.76. Okay? So these are inverse relationships, also known as arc and arc sine, arc cosine. They are synonymous with inverse. So I believe this is new, because I don't know if you guys touched on inverse with geometry, did you?
Not this kind of stuff.
Not this one. Okay. All right, does everyone have that? So notice the ratios don't change, right? So when I have inverse, it's still O over A over H, A over H. Those don't flip. You might think, oh, they're supposed to flip. No, that would be if it's reciprocal. We're not doing reciprocal. We're just doing the inverse. So when you have something like this, so cosine of some angle theta is equal to 0.237. What you have set up is you've got the A over H value here. So there's my ratio. And I'm trying to find out what was the triangle angle that produced this ratio. So now I'm going to go look at doing, and take the little capital letter TSC when we're talking about inverse stuff. So inverse cosine. And then this time, I'm not putting the angle after it because I'm looking for an angle. I'm actually going to put the ratio after it. Well, we know our ratio is a decimal value, so I don't need to write it as a fraction. I could, though. So 0.2374. And then you're going to find out what theta is. So if we stick this in the calculator, now you do your, and most of you have to access your inverse buttons by usually like shift key or second. Right? Second cosine would probably take you to inverse cosine. So go plug inverse sine of 0.2374 in there. You should still be in degree mode. And what do you get?
76.27.
So we have a 76.27 degree. Is that right? Okay. Now, How would we know we're supposed to be in degree or radians if I had a problem like this? Anyone have any idea? How would I know? If I'm supposed to be finding angles in degrees or if I'm supposed to find angles in radians? I might have theta r subscript denoting radians, yeah, or theta. But usually, either one or two things are going to happen. You're going to have a domain that's going to be given to you, like it might say, oh, we're looking for theta between 360 degrees and 0 degrees. That would tell you you're in degree limit. You might have a domain where it says, I'm looking for theta between 2 pi and 0. Now you're in degree limit. Or it just physically might say, look for my answer in radians or degrees. So let's do the same thing, but this time, let's find out what this answer is in radians. So now what do you have to do in your calculator differently? I want to find the radian answer. Switch my mode. That's all I do differently. So go change your mode to radians, and then do inverse cosine 0.2374. 1.331? Okay. 1.33 run. And that's in radians. So that's the same thing. So if I were to do the stuff we were doing yesterday, these two are equivalent. One's just in degrees and one of them is.
So if you did the conversion, it would come out like that.
Yeah. All right, how about it? Any questions so far? Braulio, you get over there. All right. Tanner, figuring out how that thing works? Sorry, need some help with that? Anything before we're going to kind of skip these other two for just the sake of skipping. Are we okay on this? All right. So let's actually do some work with the triangles. Now, when we set triangles up, right triangles, or they don't even have to be right triangles. Here's the general setup that we have. You always will have, you'll have triangle vertices labeled. And they might be labeled as a degree in a Greek letter, or they might be labeled as a capital letter versus a lowercase letter. So I could have something like this, A, B, C. Or maybe I might have beta, alpha, and then gamma, or something like that. Some different Greek letter. The sides of a triangle are always lowercase letters, and they are the lowercase of the angle they're across from. So A, little a would be across from angle A, and little c would be across from C, and little b would be. So that's just generic setup for trig functions and their triangles. Okay? So when you see this triangle here, A means that angle is angle A. And then angle beta across from C. So what's this side over here? That's C. Yeah, so C is this side, meaning that could be angle C right there. All right, so how do we solve this? If we know C is 27.3 and alpha is 47.8. Now, when it says to solve the triangle, I want all of the sides and I want all of the angles. That's what it means. Give me all the sides, give me all the angles. Well, we're missing two sides and one angle. I already know this angle. I'm going to have to find that one if it's a right triangle. We know it's not. So how do we do this? Erase all this. Kind of start over. All right, we have a couple different choices. We actually have 6 choices that I could use to find these missing parts. All 6 trig functions could work. Well, they might not all. Once I find a third side or something like that, then maybe I could use all 6. But let's figure out what I want to find here if I knew this given information. Let's start by considering the angle. That 47.8 angle tells me that this side is the what side? You guys agree with that? Is that the adjacent side? Yeah, that's the adjacent side. This is equivalent to my adjacent side. Alright, and then that means automatically this one is the opposite side. Okay, so which trig function, you know, if I had a hypotenuse and I wanted to find an adjacent side of that angle, which trig function allows me to use h's and a's? Which two trig functions allow me? Co, which is the cosine. Yeah, so if I wanted to find b, I could use the cosine of 47.8 degrees is equal to adjacent over hypotenuse. Well, we know that our adjacent is what we're looking for. And then our hypotenuse is 27.3. So I've got cosine of 47.8 is equal to b over 27.3. Okay, so let's talk about how we put this stuff into the calculator, because there is something important about that. I want 27.3 to get out of the denominator, which means I need to multiply both sides. But when I multiply it by the left side, I have to remember that cosine, sine, tangents, cotangents, secants, cosecants, they are a number. So I don't multiply 27.3 times the angle of 47.8 and then take the cosine. That's a no-no. I'm not doing that. I am taking the answer that I get in my calculator for cosine of 47.8. I'm taking that answer and then multiplying it by cosine. So generically, you're doing this. That would be my answer. So don't multiply the angle by the side. Take the trig value first, then multiply by the side. All right, what do we get to? What's b? Make sure you're back in degree mode, by the way, because we are talking about 47.8 degrees. What would I have? Okay, now here's another thing to think about. I bet some of you did this. How many of you did cosine 47.8 times 27.3? How many did that? Be honest. Did you do that? Okay, did you close the parenthesis after you did cosine of 47.8? So a lot of times what your calculators will do is you hit the, like on these CI buttons, when you hit cosine or sine or tan, it shows cosine and then throws a parenthesis. And then you're putting in the angle. And then it'll leave that parenthesis open.
Mine doesn't do that.
Yours doesn't do that? All right, so if I'm going to do that on this problem, I would do cosine 47.8, close the parenthesis, and then times 27.3. Or maybe you just do it in steps. So do cosine of 47.8, get an answer. And then take that answer and multiply by 27.3. What do you get? 18 what?
0.3.
You're mumbling.
0.33.
Thank you. 18.33. So there, 3, 4, 3, 3. Just a little rounding here. 18.33 here. Okay, how can I find A? What are my options now? I could use tangent now. I could use sine. A is an opposite. Tangent and sine both have opposites in them. So I can pick. Once I find this other side, it kind of opens up the opportunities for me to use different trig functions. So let's say we just do sine. Sine of 47.8 is equal to A over hypotenuse. All right, tell me what this one's going to be. What's my A? 20.22? 24.
Yeah, T24.
224. let's go 20.22. There's A. All right, we have one other thing, so we found A, we found B. We have one other thing to find now. And that would be this angle beta. This guy right here. Well, do I need to use a trig function to find angle beta? No. I could have done that right off the bat because it's the third angle of a triangle that has two given angles. And so I could have just quickly done, oh, beta is equal to 180 minus 90 degree angle minus the 47.8 degree angle. And we're going to get 42.8. 0.2. Yeah, 42.2. 42.2 is this beta angle. So I didn't need to do a trig function for that. I could have just done the summation of angles per time. Yeah.
Doesn't matter what use the other numbers like cos and sine.
Are you talking about for calculating A or B?
Yeah.
All right, so like for A or for B, for example, it doesn't matter which one I use. It does, actually. Before I find anything else, I have this angle here, and this is the adjacent side. So because it's an adjacent side, I have two choices. I have cosine, or I have secant. Actually, I have three choices. I could have tangent or cotangent. But the problem with those is I don't know the opposite side. So one of those two is what I would use to find sine. Make sense? Okay. Let's try this. So what's important about this? Good question from Sam. Is do these triangles always lay out where this is an A, and this is a B, and this is a C? And the question, a good one, would be no. They're not always like this. What you would probably rather do instead of that is looking at, we know we have a right triangle. And I have these two sides that were given, and typically in this textbook and in other textbooks, typically A's and B's are the legs of your triangle. The C is always your hypotenuse, typically. So if I do that and I call this my A, and then this part is my B, and then that's my C, now I can figure out how to find C. I don't need angles to find C. I can just use Pythagorean to find C. Right? C would equal the square root of 1.38 squared plus 6.73 squared. That's what C would be. I didn't need an angle to do that. But let's say we want to talk about angle alpha and angle beta. We need those two angles. Well, how do we find alpha? Alpha has a B of 6.73, which is the adjacent side to it. And it's got the A, which is 1.38, and it's opposite from it. So it has an opposite side and an adjacent. And the only two functions that have opposites and adjacents at the same time are tangents or cotangents. So I'm going to have to use, and let's just always probably just default to using sine, cosine, or tangent because we don't have the reciprocal buttons on the calculator. All right? So I have an opposite side, I have an adjacent side, meaning that the tangent of angle alpha is equal to 1.38 over 6.73. Now, we just talked about a little while ago how we find these angles. We find the angles by using an inverse. So that means if I wanted to find alpha, I'm going to do the inverse tan of 1.38 over 6.73. That's how we find angles. And then I'm in degree mode, even though it didn't specifically state which one we're supposed to be in. We're just going to work in degree mode. And if I did that, what would my angle be for those of you who worked it out already? What's the inverse tan of 1.3 over 6.73? 11.59. 11.59 degrees. All right, there's angle alpha. All right, who has the C value for me? Who's the...
I got a different answer for it.
Uh-oh.
Yeah. 0.205.
Are you in radian mode?
No, I'm definitely agree.
Are you sure?
Yeah.
All right, and did you do inverse tan? You did tan to the -1?
It's different.
Does somebody have C for me? 1.38 squared, add 6.73 squared.
Oh, it's... I can just see over.
How did I do what? Oh, why did I do that? It's Pythagorean theorem. A squared plus B squared equals C squared.
Wait, so can you not use a tangent or cosine?
Say that again?
Can you not use a tangent or cosine or anything?
No, you mean to find C?
Yeah,
Yes, I can.
because I keep trying to make it fair.
Okay, in order to use a sine or cosine or tangent to find C, I need one of these two angles first. I need alpha or beta first.
Yeah, I have it.
Okay.
I have both.
So you found alpha is 11.59?
Yeah.
Okay. Let's finish off with just doing Pythagorean. So, Summer, you not?
She got it.
You got it? Okay, because I'm doing this, right? A squared plus B squared equals C squared. For a right triangle. All right, what is it again? What? So, it's 6 point what? 6.87? Is that right?
Yeah.
That seems like it's pretty close to 6 point. This should be the longest side. It is longer, but is it okay? 6.87. 6.87. All right. So now, Bradley's question: can I use an angle to find that side? And the answer is yes. If I have that angle, which we now know is 11.59, and I have this side or this side, depending on which side I choose, I can find side C with one of my trig functions. So which one did you try to do?
Cosine.
You tried cosine. So the cosine of 11.59 would equal adjacent over hypotenuse. Is that what you did?
Yeah.
And then get the C out of the denominator. Multiply both sides by C. And we get C times the cosine of 11.59 is equal to 6.73. And now I have to divide by cosine of 11.59.
How do you...
So how do we do that? Alright, so what I would probably do is I would do this in parts. I would find out what is the cosine of 11.59. So go ahead and do that for me. What's the cosine of 11.59?
9.8. 9.98.
0.98. 0.98. And now do 6.73 divided by 0.98.
6.86 or 87.
So that's how you can use the angles to find the missing side.
Okay.
Okay? All right. So did we find all of our part? Oh no, did we find beta yet? How do we find beta? Okay, I could use sine, yeah, sure. What's the quicker way though? Because I know two angles. Subtraction from 180. I know two of the angles. Why don't we just subtract that sum from 180? So beta would be 180 minus 90 minus 11.59. You know, really, I don't even need to do the 180 minus. I can just 90 minus because it's always going to be 90. Those two angles have to add up to 90. And here we're going to get 78.41. There's my angle beta. So now I have solved the triangle. I have found all of the missing parts. Yeah?
Repeat the 180 part.
That's the, all the angles of the triangle add up to 180.
Or 90 to half.
Well, that's what I was saying. I don't actually physically need to do 180 minus 90 because the two acute angles will, for a right triangle, the two acute angles will always add up to 90. Yeah? All right, I think that's it, folks. We're gonna park it right there. You got 10 minutes.